This is a quick overview of 3 different type of pumps that are used for misting applications. This one in the center doesn't have a motor on it. These other 2 do have motors on them. The idea behind this video is to give you an idea of how the mechanics of each one of the pumps, the piston pumps themselves, work, and to weigh out the differences, specifically possibly in longevity, life of the pump. We've got 3 of them here, and they all are constructed a little bit differently. And we'll start off with the center one. This doesn't have the motor on it. This is oil lubricated. As you can see right here, there's a port for an oil sight glass. So that means there's oil in there, and it's lubricated pretty well. You do have to change the oil in there occasionally, but it's pretty much a sealed compartment, and it really doesn't have to be changed that much. Let's just say a couple thousand hours. You might see it differently. This is a cat pump in their literature, 5,000 hours or 500 hours, but this particular pump has such a short piston stroke, and the piston is in here, and it moves only about 3/8 of an inch. And so, in discussing that with cat pumps, they believe that this particular pump has the ability to last quite a bit longer, just due to the short piston stroke that's in it. This other one here is also a cat pump, and since I'm from Minnesota, all 3 of these pumps are Minnesota bred manufactured pumps. This is a Pump Tech over here on this side, but this cat pump is not oil lubricated, it's water lubricated. And that means water goes in here or here, and the discharge comes out here. And when water goes in there, the crankshaft itself that causes the pistons to go back and forth is in this case right here, which is water lubricated. That means the bearing sleeves themselves are not steel on steel. They're more like a Teflon or a nylon coating on nylon. And then encased in water. So that shows you kind of what that pump is like. Now this one here by Pump Tech is also to a degree water lubricated, but it's in a little bit different manner, and that is that this has the bearings themselves in water, where this has a mechanical bearing right in this area right here, and that mechanical bearing pushes the pistons back and forth, which have seals on them, and that mechanical bearing is open to the atmosphere. It's kind of like a wobbler bearing, and so it just sits there and wobbles back and forth and causes these pistons to go back and forth and causes the pump to pump. So this is an exposed and a greased wobbler bearing. So this one, all of them are pretty simple, low part containment, but so this really has no lubrication on the pistons themselves, except for the water coming in. There's seals on the pistons, on the rings themselves, and then there's also O-rings that are built into it to keep it sealed. But there are distinct differences between the 3. Again, oil lubricated, water lubricated, but everything is water lubricated. The cam and the cam and I forget the name of the other one. But this cam in here is more of a bearing that's exposed. You could take these apart and see that, and maybe in another video I'll do that, but I just wanted to show you the difference of the 3. Now, also, differences within the motors themselves. This is a AC motor, 120 volts, and it's a I forget the name of the class. Now I'm at a permanent split capacitor. It's a shield. I forget the name. I'll get it. But this is AC, but this is DC over here. This is open wires, and this is 0 to 90 volts DC. So you can use a DC regulator mechanism to regulate the speed of this. This is an AC motor, however, they do have options for DC. You can get 12 volt motors, 24 volt motors here. You can't get a 90 volt motor here, but here you're limited to a 90 volt motor. But you can get this pump with an AC motor. But it is a different classification of a motor than this. Okay, I remember the name of this. This is a shaded pole motor. Instead of a capacitor start or a permanent split capacitor. So the nice thing about the shaded pole motor is that you can vary the speed of it. So if you put a variac on it, something that varies the voltage supplied to it, you can actually vary the speed of this. This particular pump, when you get it, generally has the permanent split capacitor or capacitor start motors in it, and you cannot vary the speed on those. It's a little bit more difficult. Technically you shouldn't, but that permanent split capacitor runs at a constant speed of 1720 RPM, 1700 RPMs approximately. And then this one is DC, where you can vary the voltage into it to get varied output. But the other option for here is a permanent split capacitor type motor. None of these options have the shaded pole. None of the CAT options have shaded pole options. The drawback of shaded pole, it is load dependent, and what I mean by that is if you had it running at 120 volts all the time, as you have more and more pressure, more and more output out of the pump, the motor starts to slow down. Where the permanent split capacitor motor really doesn't. It runs at 1725 RPM, 1720 RPM, depending on the load output that you put on it. So there are some differences there. DC motor does slow down also, but again, you have to put a constant speed on it, constant voltage, or vary the voltage into it. So that's what I wanted to explain on these on this video. Not so much the motors, but it was the concept of how these pumps lubricate themselves. The differences between oil, water enclosed, and water not enclosed. So that should do it. Thank you.